So hello everyone. Today we're gonna try and solve a sample problem for the diesel cycle. So here it is. In an air standard diesel cycle, compression starts at 100 kPa and 300 Kelvin. So it is the initial temperature and pressure. The compression ratio is 16 to 1, and then the maximum cycle temperature is 2031 degrees Kelvin, which is at zero point 0.3, since the maximum temperature is at of a diesel engine happens at zero point 0.3. So determine the thermal efficiency. So first, we have to solve for the temperature at zero point 0.2. So temperature at zero point 0.2, given that the initial temperature is 300 degrees Kelvin, and then the pressure compression ratio, which is 16, and then the constant of 1.4 for air standard. So we can just input it there and then solve it in the calculator, and then we can get the T2, the temperature at point 2, which is 90.43 Kelvin, or 9090.43 Kelvin. So to process 2 to 3 is the isobaric process. So we have to solve for the RC, which is the clearance ratio, or the cutoff ratio, which is V3 over V2, or T3 over T2, which is equals to 2031, which is the temperature, divided by 909.43 times is equals to 2.233. So since we have already the cutoff ratio and then the clearance ratio, we can solve for the the cutoff ratio and then the compression ratio. We can already solve for the cycle efficiency, which is the from the given formula, which is efficiency is equals to 1 minus 1 over the compression ratio raised to the constant minus 1 multiplied by the quantity of the cutoff ratio raised to the constant minus 1 divided by the constant ratio times the cutoff ratio minus 1. So we just input our given form, which is the compression ratio is 16, the constant is 1.4, and then we have solved for the cutoff ratio, which is 2.233 raised to 1.4, which is the constant ratio, and then we can solve for the efficiency, which is 60.27%. So that's it. Thank you for watching.